I don't know how much experience you come from with scientific notation. I'm sure it's different from everybody. So we're going to start with the basics first and then do what we're really going to do with it. Okay? Scientific notation is a number written in the form a times 10 to the n power, where the a value, that number, is greater than or equal to 1 but less than 10. So it's got to be a single digit, not a double digit, a single digit, bigger than 1, not less than 1 or bigger, but less than 10. And then my power, my n, can be positive, negative, whatever. Okay? When we take a number and express it in standard notation, okay, like the first one here, 1.98 times 10 to the 7th power. 10 to the 7th power is a really big number. Scientific notation is used mostly in science, because in science you're often talking about very, very big things, very big, large measurements, or very microscopic, small measurements, which is why scientific notation exists. Okay? So when I am converting, when I am converting a scientific number to a standard notation, all I'm doing is moving the decimal. When you multiply anything by 10, all it does is move decimals. So 1.98 times 10 to the 7th power means that I'm going to take my decimal and move it 7 places to the right, and make it bigger. 1, 2, 3, 4, 5, 6, 7. Now, you don't really have to show me all those moving things. When I move it twice, I'm behind the 8. So I've moved it twice. So I'm going to move it 5 more spots to total 7. So that means I'm going to be putting in 5 zeros. 1, 2, 3, 4, 5. And I get 19,800,000. So 7 places to the right. Likewise on the next one, 7.25 times 10 to the 5th power. I'm going to go 5 places to the right. So 1, 2, 3.
Wait, and that's all?
That's all I want. So 1, 2, 3, 4, 5, 2 spots past the 5. So I'm going to fill in 2 zeros and end up with 712,500. So a positive power makes our number big, because 10 to the 7th and 10 to the 5th are really big numbers. When I have a negative exponent on a value or a power of 10, negative powers represent really small numbers. So this time when I do my conversion, I'm going to move my decimal to the left from where it is. So negative 8 means I'm going to move my decimal 8 spots. So without really having to write all this, I'm going to go 1, and then I'm going to have to go 7 more. So I'm going to fill in 7 zeros. 1, 2, 3, 4, 5, 6, 7, 3, 4, 0, 5. So I'm moving it once. I'll go ahead and write that for you. You can see it, but I wouldn't necessarily do this. So I move it once, and I'm going to have to go 8 times, so 7 more times. 2, 5, 6, 7. I think I moved it only 7 times. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So I don't necessarily need to move that as long as I know how many times I'm moving it. Once I get to the other side of 3, I go 7 more times. And then likewise on my next one, negative 3 power. 1, 2, 3. 2 zeros. 0, 0, 2, 5, 7. So positive powers represent very large numbers. We move our decimal to the right side. Negative numbers represent really small numbers. We move our decimal to the left side. It's going to be smaller than 1. It's likely that you've done these first 2 things we're doing, just conversions from scientific to standard, or what we're going to do now, standard to scientific. When you write a number in science, yes sir?
What number?
When you write a number in scientific notation, remember that the A, remember that's not on the 10, the A has to be a number that's 1 or greater but less than 10. So you only want one digit in front of the decimal. If there's not a decimal on a number, it's understood to be at the end. Like the number 5 is really 5.0. Okay, we don't write that, but that's what it is. So when I see 136 million, my decimal is understood to be right there, even though it's not present. If I'm going to write it in scientific notation, I'm going to move it all the way to between this 1 and 6. You move it until there's one non-zero digit in front of the decimal. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So 1.36 times 10 to the 8th power. So again, a really big number, positive exponent. Same drill on the next one. My decimal is understood to be after the 276,000. And when I write it in scientific notation, I want one digit. So that means I'm going to be between the 2 and 7. So 1, 2, 3, 4, 5. So 2.76 times 10 to the 5th power.
You wrote 5.
What?
You wrote 2.75.
Oh, why did I do that? I don't know. Because I was thinking 5 already. Was I counting when I did it? I don't know. It's Friday. Give me a break. Okay. 0.0054. Now this one has a decimal in it. So I'm going to have to move it to the right to get it to the right place. But my decimal is a really small number, so my exponent is going to be negative. So I'm going to go 1, 2, 3, 4. 4 spots. So 5.4 times 10 to the negative 4. So again, a really small number. This is why my power is negative. Scientific notation. In front of the decimal, there should be one digit. And on my next one, which is similar to that one, I'm going to move my decimal till I'm right there, between the 7 and 2. So 1, 2, 3, 4, 5. 7.21 times 10 to the negative 5th power. Yes?
Why would you not leave the decimal?
Because you only want one digit in front of here. This number here, whatever this number is, has to be between, it's coming, has to be, this A value, that number, has to be bigger than or equal to 1, but it has to be less than 10. So you can only have one digit in front of there. So if I have 72, that's 2 digits. So 72, if I move the decimal to here, 72 would be bigger than 10. So this number has to be smaller than 10, but 1 or bigger. So there can only be one digit in front. Okay, good questions. Some more questions on any of those conversions. It's likely a lot of you have done this, but probably maybe not everybody, I don't know. Okay, so here's where we're going to use it. We're going to multiply and leave our answers in scientific notation. When you multiply this is like taking 1.2 times 1,000 times 1.45 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 billion. Okay? So you're multiplying really 4 numbers together. okay? So to multiply this, easiest way is to multiply your non-power of 10 parts. So 1.2 times 1.45. So I get 1.74. And then multiply my power of 10 parts. And this is where this fits into what we're doing. When you multiply 10 to the third times 10 to the 10th, we get 10 to the what?
10 to 7.
Nope,
13.
13. What do we do when we multiply? We add exponents. So 3 plus 10 is 13. That's my answer.
We don't carry out
Nope.
line.
How many next? 3.4 times 2.3, and I get 7.82. And I have 10 to the negative 4 plus 8, fourth power. That is my answer. The next three are a little trickier. 5.1 times 9.1. Please make sure you have calculators. I don't want you having to spend your time doing that off to the side. Times, and then 2 and negative 2 give me 0. Now, I cannot leave this answer as it is because this is bigger than 10. These other ones weren't. This has 2 digits in front of the decimal. This is a number that is bigger than 10. So this is not scientific notation. So, this is how you change it. You move this decimal one spot, and it will always be 1 at the most. It cannot be anything bigger. So I'm going to make it 4.641. But if I'm going to do that, I need to add a power. So 0 plus 1 is 1. So if I'm going to change this part, I also have to change this part, or it's not the same or equal anymore. Okay? So what I did was I made the 46.41 smaller, so I made the 10 to the power bigger by 1.